We have like around 2 more minutes left.
Can everyone put their grade in the chat so I can see like around where everyone is? All right, so it doesn't look like anyone else is coming, so let's just get started. So this first part might be a review if you've already taken algebra, but since most of you have not, let's start at the basics. So basically, a system of equations is just a group of equations for which we look for values that will satisfy both of the equations at the same time. So if you have a system of two linear equations, which is just like these ones shown there, you have x plus 3y equals 6 and 2x minus 5y equals 1. Well, the solution will be an ordered pair, x, y. Well, the easiest way to look for a solution is probably just make a table and do some guess and check. So let's say we want to find an ordered pair x and y that satisfies both of these equations. Well, we can start by guessing x equals 1. And if x equals 1, you have 1 plus 3y equals 6. So that means that y will be 5/3. However, if you substitute in x as 1 and y as 5/3 into the second equation, it doesn't come out to be true. So this is not the answer we're looking for. If we try x equals 2, again, we have 2 plus 3y equals 6. That leaves us with y equals 4/3. And if you were to plug this in, you'd have into the second equation, you'd have 2 times 2 minus 5 times 4/3 equals 1. Again, this isn't true. So x cannot be 2. If we try x equals 3, we get 3 plus 3y equals 6 and y equals 1. And then when you plug this in, you would find that 2 times 3 minus 5 times 1 is equal to 1. So this is the answer we're looking for. So our solution here would be 3, 1. But obviously, when we're solving these equations, guessing and checking is probably not the best way to be solving these problems. So the solution to a system of equations is basically the same thing as its intersection point on a graph. So you see here, I graphed the two lines from earlier, x equals 3y equals 6 and 2x minus 5y equals 1. And they intersect at the point 3, 1. And that was the same answer we came to earlier. So graphing is a way that you can solve these equations. Okay, so algebraically, if you want to solve them algebraically, one of the two ways that you can solve them is through a method called substitution. So in this example, we have x plus 3y equals 4 and negative 2x plus 5y equals negative 30. And basically, the first step is to solve for one of the variables in terms of the other. So that means that we can take this first equation, x plus 3y equals 4. Let's say we want to solve, we can choose to solve for x because there's already an x here, so it'll be pretty easy. So then we have x equals 4 minus 3y after we subtract 3y from both sides. And after we have a solve for x here, we can plug this into the other equation. So basically we had negative 2x plus 5y equals negative 30. But now we can replace this x with this, with the value of x from the other equation. So then we put it here. And now you have this equation with only y's instead of having two variables. And then you can just do the arithmetic and solve the problem to get y equals negative 2. Now, once you have the value of y, you can substitute it back into one of your earlier equations and then solve for x that way. By the way, if anyone has any questions at any point, make sure to just unmute your mic and ask.
Okay. I have a question.
Yeah.
So can we like add the two equations and solve it that way?
Yeah. The adding method is it's a different strategy. It's not substitution. It's called elimination, and I'll go over it later. But substitution, yeah, if you want to add these two equations, sometimes you can eliminate terms, but that's a different method. Okay, someone else. Okay, so let's do an example.
Could you explain it again? I joined late, so I didn't understand.
Oh, okay. Okay, since a few people just joined, I'll go over it briefly again. So basically, when you're solving a system of equations, one strategy you can take is substitution. So basically in substitution, what you do is you solve for one of the variables in terms of the other variable. So in this example, we took this equation and we solved for x. So we said x is equal to 4 minus 3y from this, after we subtract 3y from both sides. Then after you do this, basically what you can do is you substitute in this value of x into the other equation. So we had negative 2x plus 5y equals negative 30. And then instead of writing x here, we can write 4 minus 3y. And then we substitute it in. And then you have one variable and one equation. Then you can do the arithmetic, the number crunching, and solve for variable. Then you plug it back into the equation and solve for the other variable. Okay, so let's do a example here. So we have 3x minus 2y equals 7 and 5x minus y equals 9. Well, we want to solve for a variable here. And since we already have a y here, it's probably easy to solve for y. So let's do that. If we want to rewrite this, we can say we can add y and subtract 9. We have y equals 5x minus 9. So now we can substitute this value in of y into this equation. Oops, this. So then we have 3x minus 2 times y, but we said y equals 5x minus 9 is equal to 7. So then we can just do some distributing here. And then that leaves with negative 7x equals negative 9. And then, or wait, not negative 9, negative 11, and then x is equal to 11 over 7. Then from here, after we find the value of x, what we do is we substitute it back into one of our earlier equations. So we know y is equal to 5x minus 9. So then we plug in our new value of x, which is 11 over 7 minus 9, which gives us negative 8 over 7. Does that make sense to everyone?
Yes.
Okay. Okay. I'll do one more example. So we have these two equations here, and when you're looking here, there's neither of these equations has a strict variable alone. So we'll have to do a little bit of manipulation here. So you see all these fractions, one of the first things you want to do is get rid of the fraction. So we can just multiply both of these equations by 2 to get rid of the denominators, because that's just annoying to look at. So the first equation becomes 6r plus s is equal to 33. And then the second one is negative 5r minus 4s equals negative 37. And then since they're all negative, we can just make these all positive. Multiply both sides by -1. So yeah. And now from the first equation, we have an s. So let's just solve for s. S would be 33 minus 6r. And after we have this, we plug it into this equation here. We have 5r plus 4 times s, which is 33 minus 6r equals 37. And then we just do the math here. Minus 24r equals 37. Negative 19r is equal to negative 95. R is 5. And then we plug it back in here. S is equal to 33 minus 6 times 5, which is 3. So our solution here would be R equals 5, S equals 3. Okay, so now we'll talk about the other way of solving system of equations, which is called elimination. So basically, in elimination, you can combine or add or subtract these two equations to try to eliminate one of the variables. So first, you have to choose a variable you want to eliminate. So look at this example here. We have a 4x and a 2x, and you notice that 4x is twice of 2x. So that means that x is going to be easy to eliminate. So let's try to eliminate x's here. So you're going to want to multiply both sides of an equation by a constant to match the coefficient of the variable to the other equation. So here the coefficient is 4, and here the coefficient is 2. So if we want to get a 4x here, so then we can subtract them, we're going to multiply the bottom equation by 2. Then this becomes 4x plus 6y is equal to negative 10 after we multiply by 2. And now we write our other equation, which was 4x minus 7y equals 13. And notice that we can just subtract these two equations from each other. So 4x minus 4x equals 0, and they cancel out, and that's what we're trying to do. Then we have 6y minus negative 7y, which is just 6y plus 7y, which is 13y, is equal to negative 10 minus 13 is negative 23. That gives us y is equal to negative 23 over 13. And if we wanted to solve for x, we just plug this value in to one of these equations again. So any questions? Okay, I'm gonna move on. We'll just do an example here of elimination, another one. So we have 5u equals negative 7 minus 2v, and 3u equals 4v minus 25. So first we choose a term to eliminate, and you'll notice that we have a negative 2v here and a 4v here, and once again, a 4 is 2 times 2. So we'll probably want to get rid of v's here. And to do that, we're going to multiply the top equation by 2 to get this 2 to change into the 4. So then we get 10u is equal to negative 14 minus 4v. And then let's write our other equation again. Well, here, if we add these two equations, our negative 4v and our 4v will cancel out. That leaves us with 13u over here. When we add them, 4v's canceled out, and then we have negative 14 and a negative 25. That gives us negative 39. Divide by 13 to get u equals negative 3. And then we can plug it back in over here. 3 times negative 3 is equal to 4v minus 25. Negative 9 is equal to 4v minus 25. 16 is equal to 4v, v equals 4. Does everyone understand how to do elimination or the basic concept behind it?
Yeah.
Okay. So let's just do, I have another example here. So in this one, one variable coefficient isn't a multiple of another, so we're gonna have to manipulate both equations here. So let's just look at 5x and 2x. Well, you could multiply this one by 2.5, but then you get decimals. So we don't want to deal with that. So let's just choose the least common multiple of 5 and 2, which is 10. So we multiply the top one by 2 and the bottom one by 5. And this gives us 10x plus 16y is equal to 40. And then on the bottom, it gives us 10x plus 25y equals 60.
Albert,
Huh?
they're asking you to go a little slower.
A little slower?
Yeah.
Oh yeah, if I'm going too fast, tell me.
Yeah, just unmute your mic, guys, so that because he can't see your thing when he's screen sharing. So unmute your mic and let him know.
You can talk to me. So yeah, here we multiply the top one by 2 to get this 10x here, and then on the bottom, when we want to get 10x, we multiply by 5. So then we're left with these two equations here. And now, if we subtract these two equations, what happens is these 10x's will cancel out. Then we're left with 16y minus 25y, which gives us -9, or -9y, which is equal to 40 minus 60, it's -20. Then if we solve for y, we get 20 over 9. And then once we know y equals 20 over 9, we plug it into our other equation, 5x plus 8 times 20 over 9 is equal to 20. And then we just do the math here. Equals 20. And I'm kind of cheating because I did this calculator, so I don't have to do fractions in my head. 60 over 9. 5x equals 20 over 9. X is equal to 4/9. So our answer is 4/9 and 20/9. So anyone want me to clarify anything? Okay. So let's talk about the solution, the possible possibilities. Well, the possibilities when you have a system of equations. So there's a possibility that you have no solutions, and this occurs when you try to solve for an equation, you end up with an equation that doesn't make sense, like 1 equals 0. And basically, this means that there's no point in which that satisfies both of these equations. And if you were to graph these two equations, there'd be parallel lines, and they'd never intersect, which is why there are no solutions. And then most often, you'll get one solution, and then a set of equations will, after you do the math on them, they'll give an ordered pair as the answer, which is what happened in all the examples. And that's basically, it's just a point of intersection of two lines. But sometimes when you combine equations, you get an equation that's always true, like 0 equals 0. And then these two equations, basically that means they have an infinite amount of solutions. If you were to graph them, you'd see that they're just the same line. And that means that, well, every point on the line is a solution, because if it's the same line, well, if it's on one line, and it's on the other line. So let's look at some examples of this. We have 2t minus r equals -1, and 5t equals 2.5 r plus 7. Well, if you look closely here, you'll see that we have 2 to 5, and then we have -1 to 2.5. So both of these are like 2.5 times of the other one. So let's multiply this top equation by 2.5. This gives us 5t minus r equals 2.5. Wait, wrong, sorry. 5t minus 2.5r is equal to 2.5. Well, if you look at, we can rewrite this as 5t is equals to 2.5r plus 2.5. Well, now when we look at this equation, it says 5t is equal to 2.5r plus 7. Well, this doesn't make any sense because when you subtract, well, this part is all the same, so we can just get rid of it. Then we have 2.5 is equal to 7. And this is not true. So this means that the system of equations would have no solutions. So if you ever end up with a false equality, that means there are no solutions. And here we have another example here. We have negative u plus 3v equals 8 and 10v minus 2u equals 16 plus 4v. Well, let's look for one of the variables to eliminate. So we have a negative u here and a 2u here. But what we should do first is we see on the second equation there's a v on both sides. So let's just move the v to the same side. So let's subtract 4v from both sides. We get 6v minus 2u is equal to 16. Well, if you divide this equation by 2, you'll notice that this becomes 3v. You get 3v minus u is equal to 8. Well, this is actually just the same thing as our original equation. So what we have here is when the two equations are the same, we have infinite solutions. So, and usually this would be the extent of where we stop and say there's infinite solutions. However, just because there's infinite solutions doesn't mean that every point is a solution. So we can still go a little further here. So what we do now is we solve for we solve for u here, and then we have 3v minus u equals 8. And then if we solve for u, we can add u to both sides and then subtract 8. U equals 3v minus 8. So what we can do now is write the solution in a form that's called parametric. So what this is usually you have an ordered pair, you have like two numbers here, but in a parametric equation, you have an expression for one number. So then it shows that there's like a range of different numbers that fit here. So our answer here would be 3t minus 8t, because there's not just one ordered pair that fits here. There's a range. There's an infinite amount of them, obviously, but any values of t that satisfy this equality will fit. And this part, this parametric stuff isn't too important in competition math, but I just thought it'd be interesting to mention here. But don't worry too much about it. All right, so in competition math, the most important thing with system of equations is you want to be able to convert the words on the page into algebra equations. So let's look at this problem. It says, 2 years ago, Jean was 9 times as old as Carol. He is now 7 times as old as she is. So what are their current ages? And in how many years from now will Jean be 5 times as old as Carol? So the first thing we want to do is define some variables. So does anyone have any ideas of what variables we could define here?
Jean's age.
Okay, so let's get Jean's age. So we can just call it G. And then we can follow suit with Carol and call Carol's age C. After we define some variables, we want to take their information and put it into an equation form.
So G is equal to C times 9.
All right. So yeah, that's the idea. But we have to be very careful here. This because it says 2 years ago, Jean was 9 times as old as Carol. So when we define their ages here, let's just say these are their current ages, just to
So
make it
G,
easy.
G minus 2 is equal to C times 9.
Almost. We have G minus 2, which is Jean's age 2 years ago, is 9 times as old as Carol's age. But Carol was also 2 years younger, so it's going to be C minus 2 as well. So this is our first equation, which we got from the first sentence. 2 years ago, Jean was 9 times as old as Carol. So we have Jean's age 2 years ago, G minus 2. We have Carol's age 2 years ago, C minus 2. He was 9 times as old, so we have the 9. Then we look at the second equation. He is now 7 times as old as she is. So does anyone want to write the equation for the second statement?
G is equal to 7C.
Yeah, so it's just G equals 7C. So now we have the system of equations, which says G equals 2 equals 9 times C minus 2, and G equals 7C. So what we do now is we solve it like a system of equations. So we already know what G is, so we can substitute it in here. We can say 7C minus 2. 7C minus 2 is equal to 9 times C minus 2. And then we'll do the math here. Let's subtract 7C from both sides. And then add 18. And then C is equal to 8. So this is Carol's age. And since we have G equals 7C, G is equal to 7 times 8.
Wait,
is,
how is it possible that 7C minus 2 is equal to 9C minus 2?
Oh, we have a parentheses here. So 9 times the quantity C minus 2. So what we do is here we distribute it, and it becomes 9C minus 18, because 9 times negative 2 is negative 18.
Yeah.
All right, good question. So then we have their 2 ages here. And then let's look at part B here. Why is it so hard to box my answer? Okay. In how many years from now will Jean be 5 times as old as Carol? So we can set up another equation here. Let's just say we don't know how many years from now it will be. So let's just call it this year's X in X years. So what this equation is saying is in X years, they're going to be, well, G was going to be G plus X years old, because he's G years old, and then X years later he'll be G plus X years old. And he'll be 5 times as old as Carol, and then Carol is going to be C plus, well, X years old. And then we know the values of C and G already, so what we do is we just plug them in here. So we have 56 plus X is equal to 5 times C, which is 8, plus X. And then what we do, we can just solve this equation now. So we have 40 plus 5X over here, and 56 plus X over here. X from both sides and subtract 40 from both sides. We have 16 equals 4x and x equals 4. So that means that in 4 years, we'll satisfy the equation, which means that Jane will be 5 times as old as Carol. And we can just go back and check this. Their current ages were 8 and 56. And in 4 years, Jane will be 12. Carol will be 12 and Jane will be 60. And then in this case, we can see that Jane, who is 60, is indeed 5 times as old as Carol, who is 12. Anyone want me to review any part of that? I went a little fast.
Yeah, can you review?
Yeah. Okay, so from the beginning, or is there a specific part that you want me to?
Just like the left side. The
Left. Oh,
yeah.
For part B, you mean? Like.
Yeah, for part. Yeah.
So okay, so it says in how many years from now will Jean be 5 times older as Carol? So this how many years is an unknown. So when we have an unknown, the first thing you want to do is just give it a variable name so that you can do some math with it. So we just called it x here. So now we can rewrite. We're looking for an equation that shows that Jean will be 5 times as old as Carol in x years. So now we want to express their ages in 5 years. So Jean's age, not in 5 years, sorry, in x years. So Jean's age in x years will be his current age plus x. So that's why we have a g plus x here. And then Carol's age in x years is c plus x as well, because it's her current age plus x years.
Yeah.
And then we know that he's going to be 5 times older, so that's where this comes. Now we have this equation here, g plus x equals 5 times the quantity c plus x. And since we already found a g and c, which were their current ages, you plug it back in, and then you can solve for x, which is what we did here. So just substitution here.
So c is equal to 8, right?
Yeah.
So how did you get 56?
Oh, the 56 came from the g plus x. And we knew that Jean was 56 years old.
Yes. Yeah, that's.
All right. I'll go ahead and clear this now. Let's try another one. Mariana has only nickels and quarters in her piggy bank. Their combined value is $9.15. Their combined weight is 1 pound. 90 nickels weigh 1 pound and 80 quarters weigh 1 pound. How many nickels does Mariana have in her piggy bank? So in this problem, let's look at our unknowns. So we don't know how many nickels or quarters they have. But what we can do is we can define variables for them. So let's call nickels, let's just call it N, and quarters, we can call it Q. Yeah, so the first step of solving any of these equations with solving any word problem is to define variables. And then we can change these variables into equations. So it says their combined value is $9.15. So does anyone have an idea of what equation we can write using N, Q, and this information of $9.15?
And N plus Q is equal to $9.15.
That's close. That's close. But N, we're calling N here the number of nickels, and Q here the number of quarters. And this is amount of money. So what we can say instead is we can say
And
that
plus equal to 1 pound.
we can say we're not going to worry about the weight yet. We can just looking at the first statement here. What we can say is that since we know the key here is to realize we know the value of a nickel. A nickel is 5 cents, and a quarter is 25 cents. And then they give us the amount of money that it's worth total. So we can set an equation here: 5 times n plus 25 times q, it's all in cents, it's equal to 915. So does this make sense to everyone? Because we defined n as the number of nickels and q as the number of quarters. So the total amount of money, which is 915, would be 5 cents for every nickel plus 25 cents for every quarter. And this adds up to $9.15, which is 915 cents. So that's our first equation here. Then we look at the second equation. Their combined weight is 1 pound, and 90 nickels weighs 1 pound, and 80 quarters weighs 1 pound. Well, if we look at 90 nickels weighs 1 pound, what that means that 90 times n is equal to 1. And then 80 quarters weighs 1 pound. Actually, we have to be careful here. I shouldn't say it like that. If 90 nickels weighs 1 pound, how many pounds does 1 nickel weigh? That's my question. If 90 nickels weighs 1 pound, how much does 1 nickel weigh?
1 divided by 90.
Yeah. So 1 nickel weight is, I'll put W there for weight, is 1/90 pounds. And then similarly, if 80 quarters weighs 1 pound, that means that the weight of every quarter is 1/80th of a pound. And now we know their combined weight is 1 pound. So does anyone want to say what equation we can set up with this information?
So 5 times 1/90th
Not quite. So
plus 25 times 1/80th is equal to 915.
We have to be careful here because this here, the reason I put W here is to distinguish it from our variables n and q here. So here we defined n and q as the number of nickels and the number of quarters. And here
So
we're talking about their weights.
So can we say 915 minus 5n is equal to 25q?
We could, but right now, what we're going to do is use this information. Their combined weight is 1 pound. And I'm going to just say right here, if we have n nickels, that means the total weight of the nickels is n times the weight of each nickel, which is 1/90. And then we do the same with the quarters. If each quarter is 1/80 pounds and we have 2 quarters, then their combined weight is q times 1/80. And then their combined weight, this is their combined weight. The mass of each nickel times the number of nickels times the mass of each quarter times the number of quarters. Its combined weight would be 1 pound. Does everyone understand this? If you want me to review this, because this might be a difficult concept to grasp immediately. But we define the variables here, n and q, as the number of nickels and the number of quarters. And we have their weights here. So when we say here, it says their combined weight is 1 pound. What we say is that the number of nickels times the weight of each nickel plus the number of quarters times the weight of each quarter is equal to. So these are our two equations here. So now, once we have these two equations, we can go to solve them. So let's look at our first equation here. It says 5n plus 25q is equal to 915. Well, we can just divide both of these by, we can divide everything by 5. So that gives us 5q is equal to, I think it's 183. Let me check. N plus 5q is equal to 183. And then we have this equation, n times 1 over 90 plus q times 1 over 80 equals 1. Well, we have fractions here with 90 and 80, so let's just get rid of the fractions. We can multiply this by 90 and 80, which is 720. So 80n plus 90q is equal to 720. And then we divide both sides by 10. 8n plus 9q is equal to 72. So now we can let's use substitution here. We solve for n here. N equals 183 minus 5q. And then what we do is we substitute it into this equation. 8n plus 9q equals 72. So it becomes 8n, and n is 183 minus 5q, is equal to, plus 9q is equal to 72. And then now it's just doing some number crunching. 1464 minus 40q plus 9q is equal to 72. Negative 31q is equal to 72 minus 1464, which is negative 1392, and then divide by negative 31 to get, let me think. By 31, you would get q equals 24. Actually, I might have done some math wrong here. Let me go back and check. Yeah, so I made an arithmetic error somewhere. So let me try to find where it is. If anyone sees where I made a mistake, go ahead and tell me. But I'm gonna check myself.
Your voice keeps on going low. Like I can't hear you. I can hear you sometimes and I can't hear you.
My microphone is not great, but it is what it is. Anyways, but the important part in this problem is to be able to set up these two equations. And when you solve for the two variables, once you have two equations and you have two variables, then the problem becomes solvable. Except in this problem, I happen to make an arithmetic error here. So that's my bad, but let me just check my answer real quick. Yeah. So when you solve these two equations, the answer you should get is quarters is 63 and nickels is there are, sorry, the quarters is 24 and the nickels are 63. So you see here that I've been doing these problems for a long time, and I'm still making mistakes here. The reason is because this is super unorganized. So when you're solving these problems, you need to make sure to keep it as organized as possible, because you're gonna make some errors somewhere along the way if you don't. And yeah, let's just move on to the next one for now. This one is a little simpler. Alex says the sum of your weight and twice mine is 361 pounds. Chris replies the sum of your weight and twice mine is 362 pounds. If they're both correct, how much do they weigh together? So who wants to take a shot at this problem? First step is defining variables as always.
So can we say C plus 8 times 2 is equal to 361?
So you're saying C is, we're defining C as Chris's weight and A as Alex's weight, right?
Yeah. And then, yeah, that's equal to 361, and A plus 2C is equal to 362.
That's correct. That's exactly right. So what you do here is, well, you define the unknowns, which are their weights, and then you put it into an equation here. So we have the sum of Chris's weight, C, plus twice of Alex's weight, which is 2A, is 361, and then
Excuse me?
yeah.
I remember another method where you multiplied C times 2, the top equation, by 2, to get 2C at plus 4A is equal to like 722.
722.
Yeah.
Mhm.
And you can subtract the equation.
Yeah. So that's the elimination method. If we multiply this first equation by 2, we can get 2C here, and then we have a 2C on the bottom. And when you subtract them, the 2C's will cancel out. And we can do that. And that's a perfectly good way to get the answer. However, in this question, there's actually a trick. So you have to pay attention to, a trick to do it a little faster. The question asks for how much do they weigh together? So that's the sum of their weight. So that's going to be A plus C. This is what we're looking for. So does anyone see a faster way we can get A plus C from this? Well, you'll notice if we add these two equations, we would get 3C, because we have a C and a 2C, and 3A from the 2A and the A is equal to the sum of 361 and 362, which is 723.
Yeah.
So now, since we're
Divide
looking
both by 3.
for A plus C, yeah, we can just divide this by 3 to get A plus C is equal to 241. So yeah, so this problem, just have to set it up, and then you don't, the last part where you add them and you notice that it's 3A plus 3C, you don't need to do that, but it's just a little trick interesting in this question that you can do to solve the problem a little bit faster. So the takeaway is that a lot of times in questions, they'll ask you something that doesn't seem like, it seems unnecessarily complex. Like, how much do they weigh together? Like A plus C. So whenever they ask you for something that isn't just the value of an variable, like isn't just a value of a variable, like they don't ask you for Alex's weight or Chris's weight, there might be keep your eyes open for like a little shortcut to see if you can do it that way. All right. Let's check the time. It's about halfway. Okay. Let's look at this question. This one's interesting. At a certain time, Heejun notices that her digital watch reads 8 minutes after 2 o'clock. 15 minutes later, it reads B minutes after 3 o'clock. She is amused to note that A is 6 times greater than B. What time was it when she looked at her watch? The second time. Well, here, they already give us our variables, so we don't have to define them. They give us A and B. So the tough part here is trying to figure out what equation we're going to set up here. So here it says it reads A minutes after 2 o'clock, and 15 minutes later, it reads B minutes after 3 o'clock.
Can we say a plus 2 is equal to x or something?
Yeah, we can set up. The key here is to realize there's something about a clock that that helps us to solve this problem. Well, it's originally 2 o'clock, right? It's 2 something, 8 minutes after 2 o'clock. And then later it's B minutes after 3 o'clock. So what does this tell us?
B is a lot greater than A.
Not quite. So but it's the right idea here. So what happens is, since it changed from 2 o'clock, we'll say like 2 whatever, 2xx, and then it becomes 3 o'clock after 15 minutes. And so the thing about a clock is you only count up to 60 here. So what you notice is that after you reach 60, you're going to restart back at 0, right? Because it's a new hour. So when you're setting up our equation here, it's originally 8 minutes after 2 o'clock, and then we're adding 15 minutes later, right? And then it reads B minutes after 3 o'clock. So the key here is to realize, since it resets at 60, we can say A plus 15 minus 60 is equal to B. So take some time to think about this. Okay. Anyone wants me to reiterate how we got here? Let me know.
What's the 2xx and the 3yy?
Okay, this is just me expressing, we don't know what time it is. It's 2 something. I just called it xx and yy here. This is just a time. It's like an arbitrary time. X and y aren't actually variables. I was just trying to show that, like, okay, it's 2 something to 3 something.
So A plus 15 is equal minus 60?
Yeah, so the reason we subtract 60 is here is because if it's A minutes after 2 o'clock and then it becomes 3 o'clock, well, when you're counting, right, let's say you're at 50, right? 5 minutes later, you'll be at 55. 6 minutes later, you'll be at 56. But 10 minutes later, you'll be back at 0 because it's a new hour. So at the new hour, 60 becomes 0. So that's why you have to subtract 60 here. And since we changed from 2 o'clock to 3 o'clock, it resets from 60 to 0. So that's why we have a minus 60 here. Does that make sense?
Yeah.
Okay. And then this is our first equation here. We can just simplify this, do 15 minus 60. A minus 45 equals B. And then we look at our second sentence here. She is amused to note that A is 6 times greater than B. So what this tells us is, well, A is 6 times greater than B. And then now we can solve this equation, right? Because we have this system of equation. So we have the value of A as 6B, so we can just plug it in to this equation. You get 6B minus 45 equals B negative 45 equals negative 5b, which gives us b is equal to 9. And then we look back. What is the question asking for? What time is it when she looked at her watch the second? Well, the second time it was b minutes after 3 o'clock, as it says here. And then that means that the time would be 3:09 p.m. Does anyone have any questions about this problem? Clarifications? Because yeah, this problem, the key here is to realize that it's a little tricky. You have to realize that when it changes from 2 o'clock to 3 o'clock, it resets from 60 to 0. So that's why you have to put this minus 60 here. Okay. Let's move on. Systems of linear equations in disguise. So sometimes you have a system of equations that don't look like the linear equations. Like you have terms like x squareds or like square roots. When you graph those, they aren't linear at all, but you can still solve it in the same way that you would solve a regular linear equation. So let's look at this problem here. Find all pairs x, y that satisfy this pair of equations. So we have 3 over x minus 2 over y equals negative 7 over 2 and 6 over x plus 4 over y. This looks a little daunting because we have the variables in the denominator. But there's a strategy we can use to solve systems of equations that we can apply here. Does anyone see it? I'll give you guys a bit, see if anyone notices it.
I have a question.
Yeah.
So, do you see the negative sign 3x minus 2y?
Mm-hmm.
Can you take that out and say minus 3x plus 2y?
Yes, you can do that. You're allowed to say negative 3x plus 2y. Or like this, yeah. You can do that.
And then put the 3x plus 2y in parentheses.
The 3x plus 2y. You cannot, when you mean like this, like do this?
Yeah.
Yeah, so the problem here is that when you do something like negative 3x plus 2y in the parentheses, it makes the negative applies to both of these. So you can't just, when you put this into parentheses, you're actually flipping the sign of one of them.
Yeah,
So,
but that's also the same as 3x plus 2 negative, and then add 3x plus 2y, right?
well, yeah, so our original equation would be negative 3 over x, negative 3 over x plus 2y, right? But if you put parentheses around here, this becomes negative 3 over x minus 2y, which is not the same as negative 3 over x plus 2y. Does that make sense? Yeah. So someone put in the chat to me, they said elimination, and this is, yeah, that's the trick we're looking for here. So let me erase this real quick. You'll notice that we have a negative 2y over here and a positive 4y over here. Well, this should scream to you that we can do an elimination here. You could also do it with x here as well, because you have a 3 over x and a 6 over x here. But let's just do it with y because the signs are already flipped. So it makes addition very nice. So if we multiply this top equation by 2, let's multiply this everything by 2. this gives us 6 over x minus 4 over y is equal to -7. And then now we can do some elimination because our other equation says 6 over x plus 4 over y is equal to 9. Well, if we add these, the negative 4y, I mean negative 4 over y and the positive 4 over y, well, they'll just cancel out. So we don't have to worry about the terms with y. We just look at 6 over x plus 6 over x is 12 over x plus 0 because they cancel out, equal to -7 plus 9 is 2. And then if we have 12 over x equals 2, well, that just means x equals 6. So and then from here, you plug it back into one of these equations to solve for y. So let's just use the second equation. We have 6 over 6 plus 4 over y equals 9. 1 plus 4 over y equals 9. 4 over y equals 8. Y equals 1/2. So then our answer would be 6 1/2. Does everyone understand what the trick was here? It was the elimination here. We had a negative 2 over y and a positive 4 over y. And then if you multiply the top one by 2, you can cancel out the 4 over y terms. All right. If I'm going too fast or you want me to review anything, feel free to
So
stop.
you said 4 over 1/2 is equal to 8? Oh,
Yeah, 4 over 1/2 is equal to 8.
Yeah, that's equal to 4 times y.
Okay. Okay, let me clear. So let's look at this one. The sum of the areas of two squares is 65, while the difference in their areas is 33. Find the sum of their parameters. So what variables can we define here? Does anyone want to define some variables? Well, the defining feature of a square would be a side length, right? So we can call the side lengths A and B because there's 2 of them. So now, what equation can we set up from the first expression here? The sum of their areas is 65.
A plus B equals 65.
Close. But well, we define A and B as the side lengths, and this is the sum of their areas. And
A times 2 plus B times 2 is equal to 65. I mean, A squared plus B squared is equal to 65.
yeah, that's correct. So it'd be A squared plus B squared is equal to 65. That's because area of a square is just its side length squared. Okay. Yes, so then, hold on, let me answer someone's question in the chat real quick. Okay, and then let's look at the second equation, or the second statement. Their difference in their areas is 33. So, well, their areas are A squared and B squared, so we can say A squared minus B squared is equal to 33. Well, we have these two equations now. Does anyone see what we can do to get rid of a variable?
Could you add the two equations?
Yeah. So if we add these two equations, since we have a b squared and a minus b squared here, the b squareds will cancel out. So this gives us 2a squared is equal to 98. Divide by 2, this gives us a squared equals 49. Which gives us
7 squared is 49.
Yeah, 7 squared is 49, so a is equal to 7. And then we can substitute this back in to find another one. So that gives us, let's just use the first one. We have 7 squared plus b squared equals 65. 49 plus b squared equals 65.
65 minus 49 is b squared.
Yeah, so b squared equals 16. B is equal to 4. All right, so now you have to be careful here because a lot of times after you're done solving the equation, what people will do is they'll just write this as the answer, but you have to pay attention to what the question is asking for. And I'm guilty of this too. I often forget. So make sure to check to look what they're asking for. So what's the sum of their parameters? What's the equation for a parameter of a square using its side length?
4a plus b, 4b is equal to.
So basically it's 4 times the side length. So we have to multiply a by 4, we have to multiply b by 4, which is equal to 11 times 4, which is equal to 44. So our answer here would be 44.
Yeah.
Does anyone have any questions? No? All right. So in the same way that we use substitution to solve a system of 2 linear equations, we can also use it to solve a system of 3 equations. And it's just a little more math because when you have 3 equations, you're also going to have 3 variables. So you follow the same process. Let me
Listen to this question.
So, oops, yeah. So let me. Okay, so what you do is you solve for one of the variables in one of the equations, just like you're solving a system of 2 equations. And then after you find this, the expression for one of the variables, you substitute it back into the other 2 equations. And then you're left with a set of 2 equations. So I'm just, the easiest way to do this is to do an example because this could be a little difficult to explain without showing how to do it. So we have these 3 equations here. So the first step, as usual, is to solve for one of the variables. And in this example, the easiest variable to solve for will be x because, well, all of the other ones have coefficients on them. This one doesn't. So let's just solve for x here. So if we can rewrite this, we can subtract 3y and add 4z. Both sides. Then we get x is equal to 25 minus 3y plus 4z. So the second step here is to take this value of x, which we found using this equation, we substitute it into the other 2 equations. So this becomes -2 times x. But instead of writing x, we write our expression for x here, which is 25 minus 3y plus 4z. And then we finish writing the equation. Plus 5y plus 7z is equal to negative 66. And here we do the same thing over here on the bottom. So we have 3x, and x is 25 minus 3y plus 4z. And then we finish writing here, minus 2y plus 3z is equal to 7. So is everyone still following so far? You solve for x using in the first equation, and you plug it in to the other two equations. Okay, so all right, if so, I'll move on. So now you have this very annoying looking math problem, and there's no way around it. You have to try to simplify it. So let's take the first one and try to simplify it. So let's do some distributing here. That gives us negative 50 plus 6y minus 8z, which plus 5y plus 7z. And now we can try to combine these terms, right? We have a 6y here and a 5y here. That gives us 11y. We have an 8z here and a 7z here. I mean, wait, what did I just say? Oh, wait, no, I said right. We have a negative 8z here and a 7z here. So negative 8 plus 7 is negative 1. So then you have 11y minus 7. And then you have a minus 50 here. So what you can do is, since it's equal to 66, you can add 50 here, add 50 here, and this gives us negative 16, because negative 66 plus 50 is negative 16. So then this equation here, when you simplify it, becomes this. And then you can do the same thing for the second equation. So when we rewrite this, this becomes 75 minus 9y plus 12z. So what I'm doing here, I'm just distributing the 3 into this term in parentheses. Minus 2y plus 3z equal to 7. Then we combine like terms here. We have a negative 9y and negative 2y to make negative 11y. Then we have 12z and we have a 12z and a 3z here. We add them, you get 15z. We have a 75 here on the left. And then we can subtract 75 from both sides. Then we have 7, we can minus 75, and that gives us 68. Sorry, negative 68. So now let's move this equation back over here. Negative 11y plus 15z equals negative 68. So, well, we have a 11y here and a negative 11y here. So the easiest path to do now is probably just going to be elimination. We can add them, so the 11y and the negative 11y's will cancel out. Then we have negative z plus 15y, so that, plus 15z, so that gives us 14z. Then we add negative 16 and negative 68 to get negative 84. And then we can divide by 14 to get z is equal to negative 6. So does everyone understand this process? Was anything like unclear? This is a pretty advanced concept. So what we did here, I'll just go over it again. Solve for x, and then plug it into other two equations, which we did here. then we just simplify the 2 equations, and then you're left with a system of only 2 equations. So we turn a system of 3 equations into a system of 2 equations, and then we can solve that using elimination or substitution. So I found z, and then if you wanted to find x or y, what you do, you just plug it back into these equations, or one of these equations. But for the sake of time, I'm not gonna plug everything back in because it's just a lot of addition, subtraction. Okay. So you can also do a system of 3 equations by elimination, but I think I'm just gonna skip it for now because I want to get to the questions at the end. So let's talk about tips for solving these systems of equations. So the rule of thumb when you have a bunch of equations and a bunch of variables is that if you have X amount of variables and X amount of equations, the equation is going to be solvable. But if you ever have more variables than you have equations, you won't be able to solve it like in a standard way through substitution. So in those questions, if you do see the number of variables is more than the number of equations, then you're going to have to keep your eye out for like some hidden trick somewhere because it is not solvable in a conventional way. All right. You always have to stay organized because there's a lot of math that goes down when you're solving a system of equations. Like earlier, I made mistakes when I was doing it because I'm writing all over the place. So make sure to try to keep it as neat as possible. Another helpful thing is in word problems, you want to choose variable names that relate to their meanings. So like remember we had quarters and nickels, we use Q and N. This just keeps things easier in the long run. And make sure to pay attention to what the question is looking for. So earlier, remember there was a question about the people's weights and it asked for what is their combined weight. And that was just hinting that, well, we found there's a trick. Instead of solving for the variables first and then adding them, there was a trick to find their combined weights. So just always make sure to pay attention to see what the question is looking for. And when you're solving a system of equations, there could be many different ways to get to the same answer. So don't be afraid to set up different equations. And here's another tip that's useful in whenever you're doing any type of algebra question. If there's an annoying expression, try renaming it as a variable. So like if you have like some like weird term like 3x plus y squared or something, you can call the entire thing like a or something. Because when you're dealing with complex terms, sometimes when you're doing algebra on them, it's hard to do. So renaming things is super helpful. And on the same note, try to eliminate fractions whenever you can, because they also make doing the algebra more annoying. So let's look at some of these more interesting questions. This question is, this one's from AMC 12, so this is a pretty tough question. In the matrix square shown, the sum of the numbers in each row, column, and diagonal are the same. 5 of these numbers are represented by V, W, X, Y, and Z. And they want you to find Y plus Z. So what are some equations we can write here?
V plus 18 plus 25 is equal to 24 plus X plus Z is equal to Y plus W plus 21.
Exactly. So every single row and column here will add up to the same amount. So that we can write this ridiculously large equation. So let's do it. Let's start with each column. So you have V plus 18 plus 25 is equal to 24 plus X plus Z, which is equal to W plus Y plus 21. So that's all the columns. Let's do the rows. It's equal to v plus 24 plus w, which is equal to 18 plus x plus y, which is equal to 25 plus z plus 21. And now let's do the two diagonals. We have v plus x plus 21, and then we have w plus x plus 25. So wow, this is a lot to process at once. So we're gonna want to see in these equations, two of them stand out from the other ones, and these are the points we want to attack. So does anyone see, out of all of these expressions here, which two of these do you think look different from the rest? I'll give you guys some time to think about it.
I'm sorry, can you repeat that? What things look different from the rest?
Yeah, two of these equations, we have 8 of them here, right? 2 of them are different from the other ones. So if anyone hasn't, I'll give you guys some time to try to find which 2 of these look different from the other ones.
V plus 18 plus 25 and 25 plus z plus 21.
Exactly. So we have these 2 equations here. So what's special about these 2 equations?
Both of those equations only have one variable.
Yeah, exactly. Also, I shouldn't call them equations, they're expressions. But yeah, these only have one variable. And the rest of them, you see, they all have 2 variables. Like the second one has x plus z, the third one has w plus y. So let's try to look at these ones with one variable first, because well, the less variables we have, the easier that the solving of the problem is going to be. So we have v plus 18 plus 25. This becomes v plus 43, and then this becomes z plus 46. So from here, does anyone have an idea of how we can, maybe using this information, we can find the value of other variables?
How we can find other things? Can we take the 2 variable ones?
Yes, exactly. So since we have a v here and a z here, what we can do here is look for some of these equations that have the v and the z in them. So let's look at this one. We have v plus 24 plus w. So these are the same. So we can write it as v plus 24 plus w. Well, now we can see that this equation becomes solvable, right? V plus 43 equals v plus 24 plus w. So we can subtract a v plus 24 from both sides. Or we can just subtract v first. And now that gives us v is 43 minus 24, which is equal to 19. I mean, not v, w. Have I been saying v? That's my bad. This is 19. Then on the same hand, we can do the same with this one. So we have z plus 46 here. Well, let's look for another equation with z. That'd be, yeah, that'd be this one. Equals to 24 plus x plus z. And when we can solve, we subtract z from both sides. 46 is equal to 24 plus x. X is equal to 22. So now, if you look, we have a diagonal here. We have 25 plus 22 plus 19 is equal to 66. So 66 is our magic number here.
Then we can also find y, because 18 plus 22 plus y is, right? Because one of the one of the rows is 18 plus 22 plus y.
Mhm.
So y has to be, y has to be like 66 minus 40 or 22. I mean, 26.
Yeah, so in case anyone didn't catch that, he's taking this row, which is 18, 22, and y. Since we know the sum here, it's going to be 66. We solve for y is 26. On the same note, we can use this bottom row, solve for z, and say 46 plus z is equal to 66.
Yeah, we can
Gives
use
us
it for b.
z is 20. So our final answer, we have to make sure they want w plus z, I mean, not w plus z, y plus z is equal to 26 plus 20, which is 46.
Yeah.
So that'd be our answer here. This, oops, why is my line drawing? So yeah, this was an interesting question, I thought. The key here is make sure to, when you have like a magic square question, then you write your expressions out, you want to look for things that stand out. And in this one, it'd be the equations with fewer variables, which was this one, v plus 18 plus 25, and then this one, which was 25 plus z plus 21. Okay. Let's look at this one. The product of two non-zero numbers is equal to twice their sum. Find the sum of their reciprocals. So I'll start us off here today. I'll start us off for this question. So let's say we have, actually, does anyone want to try to express this algebraically as an equation?
Wait, so the product x times y is equal to 2 parentheses. Sorry, x times y is equal to 2 parentheses x plus y.
Close, but it's the sum of their reciprocals. And if you don't know, reciprocal is just 1 over a number. So
Sorry, I
yeah,
didn't see that.
yeah, but you had the right idea. And then, oh wait, sorry. You're right. I'm wrong. I'm so wrong. Twice their sum.
Yeah.
I was reading the thing. So now they want us to find the sum of their reciprocals. So let's just multiply things out first. We have xy is equal to 2x plus 2y. And then this is a question. We have to pay attention to what they're looking for. They want the sum of their reciprocals. So what we're looking for, this is what we're looking for. 1 over x plus 1 over y.
So can we divide xy by something to get that?
You're very close, but let's look at this equation here, right? So which of those looks like it can become 1 over x plus 1 over y?
The 2x plus 2y.
Yeah. So here is the trick here. We have let's just look at this first term, 2 over x. How can we change this to make it look more like, actually I shouldn't say that, but the problem here is these are on the top. And here, the x's and the y's are on the top here, and here, they're in the denominator. So what can we,
both sides by 2?
divide both sides by 2? Yeah, that's a good idea. So, x plus y. Now there's something we can do here. We can turn x plus y into 1 over x plus 1 over y. So does anyone have an idea of what we can do here? Hint, it's a division. We do some division here.
Yeah, I'm trying
what-
to find out why to get that.
So everyone give it some thought.
By half?
No, that is, I mean, it's a good idea because we have a 1/2 here, but the key here is to divide. Oh, someone sent a chat in. No. So the key here is we divide by xy. So now we have 1/2 xy over xy is equal to x over xy plus y over xy. Well, now these xy's will cancel and then we'll get 1/2 is equal to 1 over y plus 1
Wait.
over x.
Did you just divide x plus y by xy?
Yeah. So
Okay.
yeah, so the key here is x plus y over xy is the same as x over xy plus y over xy. Then we can cancel out the x's and cancel out the y's to get 1 over y plus 1 over x, which was what we were looking for here. So yeah, the takeaway here is that when you have something in the numerators like this, and then you need it in the denominator later, the easiest way to do that is just divide by the terms that you already have. So if you look here, we have an x and a y here. And if we divide by xy, the x's can cancel out and the y's. We'd have a 1 over x and a 1 over y. This might be hard to see, but when you do more practice with these kinds of questions.
I was looking at it, but I thought that was just 1.
Yeah, so it's, yeah, so you got the right idea then, but which is important. But yeah, once you get more practice doing this, this will come naturally. And most of you guys are still super young. This is like more advanced. These are like high school competition questions. So if you can get a head start on it, it's great. Okay, here's a fun question. I'm thinking of a 2-digit number. If the digits of my number are reversed, the new number is 36 greater than my original number. If the tens digit of my original number is doubled and the units digit is halved, the new number is 17 greater than my original number. What is my original number? So I think I'll start us off with this one. So let's say we have a 2-digit number, and in the tens place we have A, in the ones place we have B. So let's call our number AB. This is not A times B. This is the first digit is A, the second digit is B. So let's say we have this. Now, what kind of equations can we set up here?
Can we say AB plus 36 is equal to BA?
Yeah, this is the right idea, but there's a special trick here because remember I said these are the digits of the number here, right? So this is in the tens place. This is in the ones place. So the value of something with the digits AB would be 10A plus B. Does that make sense to everyone? Because, for example,
Yeah.
If A was 2
Wait,
and B was 1. Wait, sorry? What's your question? Did someone say something? I'll just clarify this. For example, if A was 2 and B was 1, then A would be 2 times 10 plus 1 is 21. So yeah.
Yeah, so shouldn't it be 10A plus B?
Yeah, so that's why it's 10A plus B here. So
Yeah.
it's 36 greater than, let's just cross out. It's 36 greater than, wait,
Or no, that's
sorry, I did this wrong. Yeah, 36 greater than the original number. So what would the reversed one look like?
wait, I don't get what you're saying because so the original number is AB, right?
Yeah, which AB has a value of 10A plus B. That's what
Yeah,
I'm.
so let's say A was 2 and B was 1, like you said. So it would be 21, right?
Yeah.
So what it's saying is 21 plus 36 is equal to.
No. Don't think these aren't actual numbers. These are just an example to understand the concept of the 10 and the 1. These are not the real values.
Yeah, but they're adding 36 and saying that they're saying that this is I'm sorry, this plus 36 is equal to BA.
So not quite. So it says.
Bottom
Oh, sorry.
equation, so wouldn't the bottom equation be the same? 10A plus
Oh,
B
you should say it's 10A plus B
plus 30
plus 36
is equal to B 10BA.
You're right. You're right. That's my bad. Thanks for pointing that out. So it should be 10B plus A. So does this make sense to everyone then?
Yes.
Okay. So this is our first equation. And then our second equation, if the tens digit of our original number is doubled and the units digit is half, the new number is 17 greater than my original number. So what is our equation for the second statement?
What did it say if the tens digit of my original number is double? So 10A times 10, can you say 20A?
Yeah, so that's just 2 times 10A.
10.
Yeah.
Times 10A, and the units digit is half. So 2 times 10A plus B over 2
I'll just write 1/2 B. Yeah.
is equal to 10A plus B plus 17.
Exactly. So now we have our two equations. And we can just do some math to simplify this. So we have a 10A here and A here. So let's subtract A from the left side and subtract B from the right side. Plus 36. I'm skipping a few steps here, but this part is just doing some math. Then we divide by 9. A plus 4 is equal to our bottom equation. So we can subtract 10A from the left side, or from both sides, and then add, subtract B over 2 from both sides to get 10A equals B over 2 plus 17. And then we can just, let's subtract 17 from both sides. and then multiply by 2 to solve for b. So now we have a plus 4 equals b, and 20a minus 34 equals b. So this just tells us 28 minus 34 is equal to a plus 4. 19a is equal to 38, gives us a equals 2. Plug it in here. B equals 2 plus 4, which is 6. So my original number was AB. A is 2, B is 6, so that means the answer would be 26. Does everyone have any clarifications for the process of this question? Yeah, so I think the key to this question is noticing that we can write this as NA plus B, because when you're flipping the digits, it's really easy for you to change 10a plus b to 10b plus a. Okay, about 15 minutes left. Okay, this one is a little tough, but let's see what we can do here. Find all ordered pairs x, y that satisfy both of these equations. And then you have these two terms here. So
wait, you told us last time that this is like the reciprocal. Oh no, sorry. When you multiply it by that. Okay, sorry.
huh?
I thought this was the reciprocal.
It's a similar question, but the trick here is a little different. So when you're looking at this question, the first thing you want to try to do here is to you want to get rid of this. This just looks really bad on a fraction. You have a 3x minus 4y in a numerator, and here you have a 2x plus 7y. So anyone have an idea of how we can get rid of this annoying numerator term?
Can we try and get rid of the fractions first by multiplying?
Yeah, so you want to multiply both sides by xy, right? So you get 3x minus 4y equals negative 8xy, and then you get 2x plus 7y equals 43xy.
Yeah.
So when you're solving this equation here, it does get
43 times xy, right?
Yeah, 43xy here.
Oh, that's xy. Sorry, I thought that was the multiplication side.
Yeah, it can be confusing. So the problem with this is when you try to solve these equations, in the past we had like 3x minus 4y and we had a constant here, and the same with this. And when you have these xy terms, when we have these xy terms, it gets really messy when we're trying to solve it. There's actually a different path we can take here. Usually you want to get rid of the fractions and multiply by xy by true. And that's what I would have done the first time I did this problem. But there's actually a special trick here. So I remember when in the earlier question, we had x's and y's that seemed to have canceled out and gave us the form we wanted. And we can do something very similar here. So if we have this here, we can split this. So how would we split it?
3 minus 4 xy over xy.
Yeah, how would we split this? Because having two terms in a numerator is not fun.
3x over xy minus 4y over xy.
Yeah. So now, you notice what we can do? We have a terms that can cancel out because we have 3x over xy. Well, there's an x here, there's an x here. We have a 4y over xy. We can cancel out the y's here. So this becomes 3 over y minus 4 over x is equal to negative 8. And this is a lot better to work with than whatever we had earlier. And then we can do the same thing with the second equation, right? We can split this into 2x over xy plus 7y over xy. And we can call this 43. Cancel out the x's, cancel out the y's, and this gives us 2 over y plus 7 over x is equal to 43. And now we have a system of two equations that we can solve. And I'll just say the easiest way to get rid of this is to do some elimination. So we have 3 over y here and 2 over y here. So
You can
what's
subtract.
yeah, we will do elimination. We'll subtract them. So the least common multiple of 3 and 2 is 6. And so we're going to multiply this one by 2, this one by 3. 6 over y minus 8 over x is equal to negative 16. And here we have 6 over y plus, what is this? 21 over x is equal to 126.
No, sorry, 129. Yeah, 129. Sorry.
Now we can, I'm just going to rewrite it over here to make it a little easier to see.
I can't hear you.
I'm just rewriting it to make it easier to see. That's what I said.
Yeah.
Yeah. So now we can subtract these. So the 6 over y's will cancel out. Then you have a negative 8 over x minus 21 over x. So it's going to give us negative 29 over x is equal to negative 16 minus 129, which is negative 100 and 145. And now we can finish this off, and this gives us x is equal to 29 over 145, which is 1/5. And then after we know what x is, we can just plug this back into one of our other equations to solve for y. So let's plug it in here. 6 over y minus 8 over 1/5 equal to negative 16. So 6 over y minus 8 over 1/5 is just 8 times 5, which is 40. So negative 16. Add 40 to both sides. X is equal to, 6 over y is equal to 24. That gives us y is equal to 6 over 24, which is 1/4. So our answer to this question is 1/5, 1/4. So the key in this question is that you have to realize that when you have these terms like this, and then the thing that should stand out here is the terms in the numerator match the terms in the denominator. And just like in the other question, when you see these matching terms here, there should be a hint to you that there's a way to eliminate them. And in this case, what we have to do is we have to split the fractions as we did here, and then we're able to eliminate the terms. And yeah, these questions are from I'm not sure if you guys have heard of it, from the Art of Problem Solving books, and they write it's like preparation for like Olympiad math, so it's pretty tough stuff. And then it's 12:52. I do have a few more, but since we're running out of time, I don't think we're not going to do them for today. But would anyone be interested in these slides? Because I can share them with you guys if you guys want to see them.
Sure.
So
Would anyone be interested in what?
would anyone be interested in me sending out these slides to everyone? Okay,
Sure.
so I'll ask Ananya then to send them out, or you can write them, put your emails in the chat here, and I can share them directly. But yeah, and tomorrow and Wednesday, if you didn't like doing algebra tomorrow and Wednesday, they're both geometry. We're going to be looking at circles and triangles and stuff. So if this wasn't up your alley and you like doing shapes and stuff, you can drop by tomorrow. So yeah, thanks to everyone for showing up today. And yeah, you guys are free to go.
So who do we ask for this slide?